Welcome to SRA 221. In this video, we will be discussing firewalls. In the previous video, we touched on packet filtering firewalls. We discussed that the firewall applies a set of rules to each incoming IP packet and then forwards or discards the packet from the network. The firewall is also able to filter packets both coming in and out of the network, in which the filter is set up as a list of rules based on matches in the IP or TCP header. We will look at this concept more in this video. The biggest advantage to packet filtering firewalls is the simplicity to set up. Additionally, packet filtering firewalls are low cost and utilize low resources to set up, implement, and execute on networks. Some disadvantages to packet filtering firewalls is that they do not support complex, rule-based models and are also vulnerable to spoofing. Many of the protocols in the TCP/IP suite do not provide mechanisms for authenticating the source or destination of a message. They are thus vulnerable to spoofing attacks when extra precautions are not taken by applications to verify the identity of the sending or receiving host. IP spoofing and ARP spoofing in particular may be used to leverage man-in-the-middle attacks against hosts on a computer network. Spoofing attacks, which take advantage of TCP/IP suite protocols, may be mitigated with the use of firewalls capable of deep packet inspection or by taking measures to verify the identity of the sender or recipient of a message. An IP header is a prefix to an IP packet, which contains information about IP version, source IP, destination IP, time to live, etc. A TCP segment consists of a segment header and a data section. The TCP header contains 10 mandatory fields and an optional extension field. The data section follows the header. Its contents are the payload data carried for the application. The length of the data section is not specified in the TCP segment header. It can be calculated by subtracting the combined length of the TCP header and the encapsulating IP header from the total IP datagram length, specified in the IP header. Now we will look at an example of a packet firewall filtering rule set. This will be our network security policy rules. You can see here there is no incoming telnet services allowed. A computer with the IP of 132.28.6.4 cannot do telnet. UDP packets are not allowed, and outgoing telnet requests are okay. Firewall rules are preceded sequentially. When a packet is incoming or outgoing on the network, the firewall checks the rule set and compares it to the TCP/IP packet and will make a determination on how to proceed, either permitting or denying the request. A firewall rule set will look like the table shown and will contain the policy firewall rule, packet direction, source and destination address, packet type, source and destination port, the ACK field, and the action field for the firewall to take. The first rule we discussed earlier is that we did not want any incoming telnet service on the network. So in our firewall table, we have the following information. You will see that this rule is Rule A. The packet direction is incoming, the source is external, destination is incoming, and the source port is in any port. The destination port is 23, telnet. The protocol is TCP. ACK is 0, stops communication. And we want the firewall to deny this request. In our rule set, we also identified that outgoing telnet requests would be permitted. To make this rule work, we actually need to have two packet filtering rules in our firewall. Since this is the case, you can see the rule set above, Rule D, will be allowing outgoing packets to the outside telnet server. In our rule set, we also identified that outgoing telnet requests would be permitted. To make this rule work, we actually need to have two packet filtering rules in our firewall. Since this is the case, you can see the rule set above, Rule D, will be allowing outgoing packets to the outside telnet server. You will see that the source IP should be internal, the destination should be external, and the source port can be any. However, the destination port must be 23, indicating it is a telnet application. The direction is outbound, the protocol is TCP, and the ACK is 0 or 1, because we need to allow both. Otherwise, the telnet connection cannot be established. And last, you will see to permit this request. We also have an additional rule to allow the incoming packets into the network from the outside telnet server, which is indicated by Rule E. So you may be wondering, didn't we put Rule A as not allowing telnet requests? The distinction between Rule A and Rule E is that Rule A doesn't allow any requests from the outside to come inside, but Rule E will allow the packets to come back into the network after a request has been made.